see we already have some attendees popping up. We're going to give it a little bit longer for folks to join us, but we will get started here shortly. But thanks for joining us. We've still got some folks trickling in here, so we're going to give it a little bit more time. But in the meantime, we are curious for those who are joining us, how many of you are using Solidworks, or what is your, I suppose, software of choice, whether that's Solidworks, Autodesk, if you're solely in Illustrator to create your two-dimensional files. You can pop that into the chat and kind of let us know. And we're just curious to see what our spread is today and see how many folks are just experiencing SolidWorks for the first time today, or where the majority lies. So go ahead and drop that into the chat while folks are still trickling in.
I'm getting told that chat is currently disabled for participants, attendees.
Oh, that's interesting. We use actually the question and answer section for that, and then we'll be able to see those. But I do see Dave said SolidWorks and Inventor. Okay, that's great. No. Oh, Scott's using Fusion. Raj, hopefully I'm pronouncing that right. SolidWorks, Roger, SolidWorks. That's awesome. Great. So hopefully you learned something with me today as I walk you through kind of how we're making this file. And then I'm sure there's a lot of folks here that are much more talented and skilled than I am with SolidWorks, but we're gonna do our best. And like I said, hopefully you'll learn something. And at the very least, you'll get to see our systems and how they cut and how the workflow actually takes or looks like, right? So we are going to go ahead and get started. Let's switch over here. So this is, oh my goodness, give me 1 second, sorry folks. So this is FabLight Flow. Thank you for joining us. My name is John. And this is our first time doing the FabLight Flow webinar. This is a brand new event for us where we're going to be showing you how to go from idea to cut parts in our time today. First, we want to welcome all of our current FabLight family members who have joined us today. It is really great to see some familiar names out there. And then we also want to welcome all those folks who are getting to know us and are well on their way to joining our family of businesses, universities, and everything in between that trust FabLight systems for their in-house metal cutting needs. Because this is our first FabLight Flow event, we really want to hear from you when we're done, whether you want to reach out and let us know that this was exactly what you were looking for, or if you want to tell us in a really friendly way that this kind of missed the mark, you were expecting something different. We still want to know. We want to be helpful to everybody, not just our new folks, but our old folks or our FabLight family included, right? So we'll be sending a follow-up email later with a link to a recording of this webinar, and you can respond directly to that email to give us feedback. So this is our agenda for the day. I'm going to go through a brief intro, but then we're going to get right into the FabLight Flow right away, and then we're going to design our flat pack grill completely in SolidWorks. We're going to go to import that into FabCreator, and then we're going to cut it out. We're also going to do a small overview today for our new customers while that cut is taking place, and then we're going to get into the Q&A with our remaining time. If you have questions throughout the webinar, please feel free to drop those in the chat. We've got myself, I'm John, and Jennifer and David in the chat for those questions for you to answer. And so I'm the product marketing manager here at 3D FabLight. Many of you are already speaking with Jennifer or have spoken with Jennifer, who is our national account manager. who's behind the scenes answering some of those sales questions for you. And she may answer some of those in the chat or highlight them here to answer live. And then certainly, but not least, we have David, our man of mystery, our Wilson, our applications engineer, and that's our webinar expert today on everything FabLight. David will be answering some of those more technical questions throughout the webinar and during our Q&A, and he's got some really great SolidWorks experience too. For those who don't know or don't already follow us, make sure you're checking us out on Instagram, Twitter, LinkedIn, YouTube, Facebook. We're everywhere, where you can find all of our brand new projects that we've been cutting. We did this grill earlier this week, or last week, actually, I should say. We're doing other projects. We're trying to do a new project every week or so. So make sure you're checking those out. And some of these projects will actually even turn into their own FabLight Flow events to show how we made them. But enough with the chit chat. We're just going to go ahead and get started and get into our workflow. So as with any new project, we're going to start off with a little research, and there are plenty of folks that have made flat pack grills. This is definitely not a new concept. We didn't come up with this, but we were definitely excited to take on the challenge. So we looked around, kind of looked at what worked for some of these other ideas, what didn't work, what did we want to integrate into our own designs, and then kind of took it from there. So we have our FabLight system here. This is what we're actually going to be cutting on today. And you should be able to see, this is actually our grill made up of 6 parts. So we got our grilling surface. We have a center crossbar here in the middle, which I'll show you a little bit later. Got our 2 side walls, and then we have our front and back walls as well. I'm not sure if you can see down below. Maybe I'll move it down here, but we actually have the rest of our grill, a second grill down here. So we're going to cut the last face of that grill and put it all together for you all, so that you can see how we're doing that. Just wanted to show you so you have a reference and an idea of what we're doing today. And then for our new customers, this is our FabLight FL4500, but we'll get into more of the details behind our systems and why they're so great, okay? Let me switch back. We're going to go back to SolidWorks. And again, if you have any questions during this, please feel free to drop them in the chat. We will do our best to answer them live. So first, we're going to make our front wall for our grill. This is going to consist of 2 rectangles. We're going to dimension this out. We're going to call this bottom one 12 inches. We're going to call this side 9. And we're going to make a second rectangle actually here that stacks on top of this. This rectangle up top is actually going to act as our handle later on. And we're doing this to establish some geometry up here because we're going to use this center line, but we want to have something to reference off of there, right? And of course, like I said earlier, there are a ton of ways to do this. This is just one path. I'm sure there's a ton of folks here that are way more skilled in SolidWorks than I am. This is just the way I found to do it and the way that I thought was most effective. So, but I'm sure there's other ways to go about it. There's a lot of different ways to skin a cat. So here, we're just going to add a 1.5 inch fillet to round off all of this. I'm going to add a center line here as well. I'm going to try to run through this as fast as possible because I know we are limited on time, and I do want to be respectful of everybody's time. But again, if you have questions, throw them in the chat. We are going to offset some of this. We're going to go inside by about 1/2 inch. And today, just so you know, we're cutting on 1/8 inch cold rolled steel. So this is, you know, looking at the dimensions, we're about 12 inches wide by 11 inches tall. This is a hefty piece of material, a hefty part. So we are going to try to save some of that, or cut some of that material out to save some weight as well. Here, we're going to offset this to create the bottom or a reference for the bottom of our grilling surface. So I'm going to do 1/8 inch to represent that. We're going to reverse that, so that's offset there. Now, the next piece we want to cut or create is a slot here. You may have seen it. It's for our crossbar. We want to create this slot here in the middle. What we're going to do, take a couple of rectangles, and actually we're going to change this to a center rectangle. We want this right off of that center line. We're going to dimension this. We're going to call this 2 inches. We're going to do another one right above it. We're going to call this one 3 inches. And we're going to dimension each of these sides by about 3/16 of an inch. So just a little bit thicker than our material, but that will allow us to get that crossbar in there really easy without having to any difficulties locating it. We are going to make these collinear, so that these sit right on top of each other. We're going to do one more dimension here. We're going to have this crossbar, the slot for this crossbar at least, at about 3 inches off the ground, just to give it some space so that those poles and everything are not sitting right on the ground down at the bottom there, right? Then we're going to come in here. We're going to trim. And folks, if there's something you see in here that's new to you, I would love to know what that is, so that, you know, maybe I'm teaching folks out there something new. So I would, like I said, I'd love to know that. If you're seeing something that you've never seen before, or technique that you've never seen before, that'd be great. But now we've got this slot here for our crossbar, so that'll come in through the top here, and we'll create a couple of grooves and tabs on the outside of this, so that this crossbar will sit right in there and be really easy to locate. Okay. So this next piece, we're actually going to start working on our sidewalls already. And so we're going to draw this center line. This is going to be our construction line, and we're going to call this our sidewall. We're actually going to offset this. So we're going to divide this by 2. That's the thickness of our material, and we're going to go bidirectionally. So that'll make our 1/8 inch material. And we're going to cap each of these ends. I'm going to show you why we're doing it this way here in just a second. So we're going to do that. Now, we want to take this point, we want to make it coincident with this center line here, because we want these two sidewalls to match or meet right in the middle there. We're going to do that. It's going to move over. Then we also want this to get as close to that crossbar without blocking the slot, without getting in the way of that crossbar. So we're going to make this sidewall of this, the side of this sidewall, sorry, coincident with this point, this furthest out point here. So we're going to do coincident. Okay. Now I'm going to drag this over just a little bit, just so I can visualize a little bit easier. But I do want to take this center line, and personally, I wanted this to go straight through this point that we have up here. And now we can start to see what we're creating here. This is our sidewall kind of reference shape that we're going to be using, and we're actually going to use this shape to actually make the sidewall later on, and I'll show you how to do that. But we can start to see how this is coming into play. The last one that we want to add a relation to here is this point, this line here. Now, you can leave it this way. You can give this some height if you want. If you wanted this sidewall to actually extend up past what we're calling, again, if you remember, we called this kind of our grilling surface, the top of this or the bottom of this handle shape that we're creating here. This is the bottom of our grilling surface. This is going to be the top of our grilling surface. Again, 1/8 of an inch, that represents our material. We could have this extend out past that, so you have a little bit of a lip to your grill. Or what we're going to do, what I decided to do for this grill, is actually make this coincident. So now you have this flush surface. I found this really useful because we're actually going to create notches in this sidewall here that are perfect for sticking a skewer in and resting a skewer on, I should say, or even holding a stick up and propping that up to roast some marshmallows, which if you saw in that first slide and that GIF, you can see where we were roasting some marshmallows to test out this product fully a couple weekends ago. Okay, so now we have this sidewall here. Move some of these references, some of these dimensions, because I'm also going to add a center line here. I'll show you why here in just a minute. First, I'm going to select this whole sidewall. We're going to select that center line that we just made. We're going to grab this center line here and mirror this. All right, so now we have basically the important structure of our front and back walls. We have our crossbar here. We have our two sidewall slots and our two sidewall shapes. And then we have our handle here, right? And this is all dimensioned out so that if we wanted to, and we did on our side, we actually made this a lot shorter. Originally, it was quite a bit wider, but because we've got all these great references in here, this is really easy to manipulate and change the shape up. So we're going to exit out of this though, because we're going to switch step 2. Now, I'm going to take a little bit of a jump here, but it's hopefully not hard for you all to imagine what we did here. So all we did was we inset this line out here and offset it by 1/2 inch to match again with the rest of this handle. And then we created another line that was parallel to this side slot here and offset it by I think about 1/4 inch down here from this center line so that we could create some open holes, again, to reduce the weight of this. This is really bulky material, really heavy. So we want to be able to reduce as much weight as possible while still being really functional and stable, right? So what we did, we also added some additional slots here, and these are just tangent, again, to another parallel line that's been offset by about 1/2 inch. And this is to create some airflow through this grill face here. Okay, so what we're going to do is we're going to go ahead and start to extrude this. We're not going to do a thin feature, but we are going to select some of these contours here. We're going to select this one. We want to keep some of these. And I know some of this is obvious to me. It may not be as obvious to you. So if you have questions about why are we selecting some of these regions, please feel free to drop that in the chat. But this, hopefully you can start to see again, we're starting to get that handle shape. We're getting the side wall of that grill, and then we're getting the frame structure down here. Now, we got to remember these last two parts because these are pretty important. So remember that center line that I created here. We're actually going to come back and use that center line to split that sidewall that we made. And we're going to select these regions down here because we want this to meet in the middle of these two materials when we create these parts, right? And then we're going to have this extrude by about 1/8 of an inch. Okay, so there we are. This is our first part. You can start to see it come alive, start to see what we're actually going for. Again, I'm going to skip ahead because I want to save some time here. We're going to jump to step 3. And all I really did here was add fillets to all of these sharp corners that I had here. So we rounded a lot of these out. But again, don't want to take your time. I'm sure folks who, especially if you have experience, you know how to do that. There's quick ways to do that. So we are going to move on to actually creating that sidewall now. So I'm going to come here, take a look. I'm going to grab this sketch. We're going to do a new extrusion based off of that sketch. And this time, we want to get the opposite side of that sidewall. So we're going to select this region. We need to come in here, and we need to make sure that we're selecting all of these important regions here, right? So there's 3 altogether. Don't want to forget any of this. We don't want to create kind of a 3-dimensional shape. We want to make sure that this is all 2-dimensional, right? And so we're grabbing that now. We're going to extrude that by 1/8 of an inch. This time, though, we are not going to merge this result. This is a completely new part. We don't want to merge this, so we're going to uncheck that merge result. And now we've got the beginning of our sidewall here. We're going to come back into the sketch. We're going to do a new extrusion. This time, we want to make sure that we're extruding from this face here. Excuse me, not from this back sketch plane, but we want to extrude from the front of this face here. And we're going to come back in. We're going to take a look at this contour that we have here. Take a look at the front so you all can see. We're selecting that whole rectangle because this is the rest of the sidewall material that we're actually going to take and add to that little center slot that we did. So this time, we are going to leave merge result on, but we're going to deselect the auto select because we don't want this body, this new body that we're going to create, to merge to our original part, right? We want it to just merge to this, okay? So we selected our correct bodies. We're going to extrude this actually 1/4 of an inch. You can extrude it a little further if you want, but hopefully that's enough. At least when I made this, this was enough material for us to hang on and really grab onto that front wall, okay? All right, so now we're seeing the outside of this. Let's make the inside. We're going to come back to this one more time. We're going to extrude. We're going to grab this rectangle. This time we're going to go in the opposite direction. Leave that merge result on. Keep those contours there. Deselect the auto select and grab this body here. That's the body we want to merge to, not our original face. And then this time, depending on how long you want the grill to be, I'm going to make this one 6 inches because we're eventually going to double that by mirroring this part. But if you want to make it, the full length of it 18, you would obviously do 9 inches. So we're going to do 6 inches and we're going to say, okay. Okay, so now we have half of our sidewall here. Now we're going to mirror this. We're going to come in here, grab this face, I'm going to select some bodies. Select this body, and then we're going to hit okay. Okay. Now we have that. Got 2 pieces to our sidewall though. That's not really going to work out. So what we're going to do, make sure you have your command search on, not one of these other searches, but we're going to do command search. And we're going to come in here and say combine. Now we're going to combine these 2 bodies together to make one solid body. Okay, so now we see our full sidewall there. We're going to come parallel to, or normal to it so that we can take a look from the top. Now we're going to add some features to this. So what we're going to do is create a reference plane down here. I'm going to grab this face because again, this top face for this handle should be the top of our grilling surface, or in our design, that's what we want the top of our grilling surface to meet up with, right? So we're going to select this, and then we're going to flip the offset of our plane, and we're going to call this 1/8 of an inch. Now we have a plane where we want it to be for our grilling surface. Extend this out a little bit, send it here, and go this way. And this time, to make sure, because of the geometries in here and because of the angle that we put into this, we're actually going to cut this so that we know exactly where the bottom of this grilling surface intersects with this sidewall here, okay? So we're going to come in here. We're going to say, let's split this. We're going to select our trim tool. Our trim tool is actually going to be that plane, again, because we want to know where this plane intersects with this body. And this is the body that we want to intersect it with. We're going to cut that. Now we've got 2 shapes. We're going to select both of them. Okay. So now we come in here, turn off this plane. We can see our geometry. Now this line, again, that's the bottom of the grilling surface. That's where we want this to intersect. And that's where we're going to base our notches off of. So we're going to create a new sketch on this one. And then we're going to convert this entity so that we can use that as a reference. We're going to create some construction lines from that. And then we're going to create a new corner rectangle here. Okay. And we're going to dimension this. In our design, we ended up dimensioning it about a 1/2 inch away. And then we called these slots. Again, you can change this however you want, you see fit. We called these slots 2 inches wide. So quick math, we're going to multiply or linearly pattern this rectangle in the X direction 3 times. And then we're actually going to have it spaced out 2.5 inches. So we need 2 inches for the original rectangle plus the 2.5 inches there to get that spaced out evenly. Okay. Alrighty. Get out of here. Now we have our notches. So we can take this sketch, we can extrude this cut, and this time we're going to cut through everything, cut through all, and we're going to say all bodies. And it's asking us which bodies do we want to keep. We want to keep all of them. We're going to combine this part. 1, 2, 3, 4, 5. So that's our main body and the 3 notches that we created from that split body. And now we have our sidewall with our notches in there that's ready for that grilling surface to be designed. Okay. Now we're going to close out of this one too, and jump ahead, because we've already added some of these little features that you can definitely come in here and add around some of these corners, add some of these little semicircle notches into the space between the notches, again, so that you can lay a shish kebab or s'mores or what have you, whatever's on a stick, you can lay it right across there, right? Okay. So now we need to come back in here and design our grilling surface. So we're going to use that same plane that we had earlier. We're going to take a look from above. And then we're going to come in here and add a new sketch. But this time we're actually going to do I'm going to do a center rectangle. I'm going to line this edge here. Again, this is our foremost edge on our sidewall. So this is exactly where this grilling surface is going to meet up. So we want those two to be collinear with each other. And this is our front and back wall. We want that to be collinear with each other too. And this here is going to be collinear with the center, because we're going to do some mirroring here in just a second. And then actually I'm going to select this midpoint here first. And we're going to select this line and make that coincident. So now we've got a quarter of our grilling surface here. Come down in here. I'm going to add a couple more rectangles. So this one to meet up there. Whoops. Change that to a corner rectangle. And then we're going to have this extend out to be collinear with the corner of our sidewall here. Okay. We're going to do the same down here. We're only going to make a half rectangle this time. But we're also going to make that in line with our wall there. And then we're going to make this just collinear with this one here. Okay. So then we can come in here. It's smart to go ahead and add our fillets in here. We'll do 1, 2, 3. We'll do 3 for now. And we're going to round this one a little bit differently. We're going to give this a bigger rounding. I'm going to call this a 1/4 inch. Okay. So there's a quarter of our grilling surface. We're going to select, actually, we're just going to go ahead and select all of that material. We're going to mirror it. We're going to go first to our right, say OK, grab it all again, mirror it down. There we go. We can delete some of these lines here. We have our grilling surface. Now, what we'll do, take that sketch, we're going to extrude it. And should grab everything, but we'll go ahead and do this. Probably because we didn't trim some of these segments here to make this one continuous shape. That's okay. All we have to do is grab some of these segments or some of these sections. And then remember, brand new part, we're not going to merge that. And then we're going to extrude that 1/8 of an inch. Voila. We have our grilling surface here. So I am going to skip one more time, again, just to save as much time as we can here. But what we would normally do is actually create a center line here in the middle of this grilling surface, or just use one of those center lines that we just created. Show you what that looks like. We actually create those grilling grates there. So we see them all throughout. And then we used a linear pattern, so we created a line here, and I think I can actually show you what that actually looks like. Oops, I can't. We created a line here that actually extended past this original reference square, and then had that repeat all the way down, and then created a slot that intersected at those 2 points over there. One thing that I actually forgot to show you in the previous one, but I will go ahead and kind of show you what it looks like, at least. That crossbar that we talked about. So this is what our crossbar looks like. Again, really, this is fairly simple to make, so I'm not going to go too into detail on how to do that. But all we did was take the geometry of the tab slots that we saw earlier, or that we created earlier, and made that so that this crossbar is now going to interlock there. So you can, again, easily locate it, make it a little bit less wide than the actual slot above, and then locate it using those tabs there. Really quick and easy way to do that, right? So that's that. Fairly simple, fairly straightforward. What I would do now, I'm not going to show you this part, but what we would do is we would take this and we would create a DXF file. You could either do this, you could do this a few different ways. You could create a solid or a part file for each one of these, export it as a DXF, or you could take this all into an assembly, flatten it out, and then bring it into a solid part file, and then export it as a DXF. I can actually show you that real quick. So again, we brought all of those files into an assembly. This is our original really large format grill that we originally did. So we brought all these files in, did some mates, kind of did our own nesting here, and then we spaced these out about 1/8 of an inch between all of these parts here. And then all we did was we created a Solidworks part file. And David, you may have actually a better way to do this. I don't know. This is the way that I found was easy for me, but I created a Solidworks part file, and then I just exported that as our DXF. Okay, so we would save that DXF, and that's what we're actually going to bring into SolidWorks. David, do you have a better way of doing that, or an easier way that you know of?
Not off the top of my head, I'd have to look into it.
Okay, great. So, and folks, especially for our experienced users with SolidWorks, if there's an easier way to do that, you know, definitely drop that in the Q&A section at least, and let us know what you think. Okay. So for now, we are going to switch over to FabCreator. Don't think you all can see the screen. Wait 1 second. Hopefully you all can see this FabCreator screen now. David, can you confirm that for me?
Yes.
Great, thank you. But we're going to come back in, and now we're going to export this into our software. So today I will show you how to export this whole project, or actually just one of these parts. But normally you would do the whole assembly file if you can fit all of that into one part. So let me see, which one do I want to pick? So we're going to import this for units, inches, moving it to the origin and auto placing it. And so there we can see this is our layout. This is all 6 of our parts, our 2 sidewalls, our front, back, our grilling surface, and our crossbar. Now, we can come in here and you'll see our tabs. We have part, edit, properties, process, and job. In FabCreator, this is set up this way so that you can easily flow from one to the other. So you should start with your part tab, go into edit, go into properties, go into process, and then you finish off in your job tab. But we can take a look here and we can see our cut folders. If we had other geometry in here that we wanted to move around, say we wanted to take some of this geometry and move it to an engrave instead of a cut, we could easily do that by just right-clicking on it, selecting it, and then going to move to engrave. Or if we wanted to take a bunch of these, we could do that too, drag and drop into those folders if they're down below. We can do all of that really quickly and easily. We're not going to move any of this though today. We're actually just going to go into our edit tab. If we wanted to, we could definitely take these parts here and rotate them. We're not going to do that today, but again, really quickly and easily that can be done.
Hey, John, I'm getting a lot of people wondering if you're going to be sharing these files after the webinar.
I am going to be sharing these files after the webinar. That's a great question. So folks, I'm going to send this out for all the folks who have FabLight. This is going to be ready to go for you. We're actually going to send you the FabCreator file so you can cut this. This is going to be created for a 1/8 inch cold rolled steel file. So if you need to make modifications to the Solidworks file or modifications to the DXF, I'm going to send those parts or those files as well, so that you have those, so that you can do all those modifications yourself. And we would really, really love it if you actually share those with us on social media, or if you just want to shoot us an email and say, hey, I made one of the grills, and you took a picture of it and show us cooking the burgers or hot dogs on that, whatever. That'd be great too. We'd really love to see those projects. So we're going to move into our properties tab. We're going to select our machine. So we've got our FL4500 here. We have our sheet. We're not doing any tubes on this project. Maybe in a future FabLight Flow, if that's what you want to see, let us know. We would love to do a tube project for you all. But today we're just doing sheet, and then we're going to select our steel CRS down here. Our material is typical, and we're going to select a 1/8 inch thickness. That's it. That's all we have to do on this tab. So we click accept. Now we're going to go into here and we're going to tab some of these parts up. Now, excuse me, the reason we want to tab some of these parts, these are fairly large spaces that we're actually going to be cutting out of here. So we want to tab these so that they stay in the part for now. And all we're doing is we're just creating a tiny little tab, 0.15 of a millimeter thickness here. So we're just going to create some tiny little tabs here because we don't want these parts to fall around or jump up or anything like that and get in the way of that cutting head. So we just simply come in here, add a bunch of tabs. We can add them all over the place here. If we don't like where a tab is, we can easily come in here, delete a tab. We can delete all our tabs. We can do all of that right in here. So normally, again, like I said, we would come in here and we would tab up all of these parts because we don't want any of these to get in the way of our cutting head, okay? That's just kind of good practices. David, I don't know if you have anything else to add to that.
Yeah, well, tabs provide two different things. As you said, they keep your parts in place and they also prevent tip ups. So like those long parts that you have would easily fall through, generally speaking, but when doing that, they might also hop up and hit those our capacitive height sensor, causing a tip touch. The one thing I would like to say is that if something is really giving you a lot of trouble, one thing that you can do is go into your CAD software and cut relief lines in that part so that it falls apart into smaller pieces. So you can cut up those long lines into smaller lines, those big triangles into small triangles, and that way you would get less risk of tip ups and stuff like that.
Yeah, that's great advice. Thanks, David. So for these tabs, we're going to just go ahead and say we're done here. We're going to skip over into our job. Okay, and this, all we're doing here, we're just going to take a look at our job preview. We just want to make sure that we're cutting the right thing. We want to show slews so that we can see how the cutting head is actually going to move around this part here. So we're going to start down here in our bottom left corner and cut all these slots out, cut our grilling surface, and then we're going to move up to the top here. And then simply make and save. And then we're all done. So that's going to be our FabLight file. If there's interest, I can send out the larger file. Folks, I do want to tell you that this does take up a large chunk of a 24 by 48 inch sheet. For this one project, I think our larger one took up most of it. So we can still send that part out though if you're really wanting to get one of these grills in your hand. So and cut it out your own, we can definitely do that. But the smaller one still leaves you with some room on a 24 by 48 inch sheet to work with. Okay. So now what I'm actually going to do, I'm going to move our camera here. This is the human machine interface, the HMI of our system. Sorry about that, folks. So what we have here, we have our key ignition, our emergency stop, start and stop buttons, and then we have a 7-inch touch display where you'll be actually doing all your controls, and then we have our USB device. So we've actually already loaded up our cutting file that we're going to use today onto this USB. We plugged it in, so we're just going to go to new job, and I'm going to try my best to stay out of your way here. We're going to go find our file. And then we're going to do the grill front for webinar. We're going to select our file. So now we see our cut information and this is all been imported now or matching up to our FabCreator file. So we already know what our feed rate is, what our power level is, what our frequency, our pressure, everything is already done for us. There's no guesswork. You don't have to try to figure out what's going on there, right? And we can see our preview file. We can see the file that we're actually going to cut. Again, we're just going to cut this small little face to try to save some time today. Oops, went a little too far back, so let me go back here. We're going to hit OK. And now I'm actually going to switch. So you can see on here, again, this is mainly for our new folks. We have a jog screen here. So you can kind of see over here, our cutting head is actually moving. If we had a sheet down here that maybe had a gap in it because of another part that we cut, we can actually move around here really easily by just touching these and dragging them, or we can actually double click. Oops. My hands are a little moist, folks, so you'll have to, yeah, there we go. So we double click on that, and we can see, we can actually hone in and say, let's just do 2 inches. But today, we're just going to do right into the corner. I'm going to show you the inside of that machine actually real quick. There we are. So now again, just really quick, we can show you, we can jog around that screen really easily. I'm going to open this door and you'll be able to see my hand here. We have our cutting head. We have our material already loaded up. With our material, we're actually going to load this up into this easy drawer that we see here. So you just load this up, make sure you secure these tabs down here, the 4 tabs that we have on the left for your material. That's serving 2 purposes. It's one purpose is to hold down the material tightly to make sure that it's not going to actually move around while the cutting head is in action. And then it's also providing ground to our material as well, so that we're actually being able to detect with that capacitive height sensor that we have on our cutting head where this material is, so that if there's any bowing or anything like that in this material, we're going to be able to detect that and cut appropriately, right? Okay, so that's that. We're going to go ahead and run this job. And I'm going to leave this camera on here for a while. We're going to press our start button, and hopefully you'll be able to hear me still pretty clearly. But I am going to go through our deck. Let's do this one. Yeah, perfect. So there we go. So now you can see us, and hopefully that's not too loud. But for all of our new customers, and maybe for some, maybe even for some of our old customers, we're going to run through some of what FabLight is about and some of our system. Again, make sure you're sticking around till the end to hear about the special webinar offer and the referral program that we're kicking up today. But about FabLight, we make high quality lasers that really combine functionality, flexibility, and cost effectiveness all in one package. Historically, this is a manufacturing technique that has been limited to large production facilities or high-end labs that have, you know, huge budgets for sheet-only machines. Here, we've got sheet and shoot cutting functionality packed into 21 square feet. Second, we've got complete vertical integration here. We're doing hardware, software, and service all here in-house. That means we're responding to your issues a lot faster. We're not passing you off to anyone else. You're not waiting around for someone to give you an answer. We're the ones doing the answering here. Lastly, we were founded in 2016, and we've always been here in California. We make our machines here in California, and we're really proud of that. Actually, that photo that you see to the right there, if you can see it, that's our facility here in the heart of Oakland. And this is where we have our engineers, our sales team, and our service all based out of. We have customers really in a wide range of industries that take advantage of how affordable our systems are. Companies like Ford, Amazon Labs 126, universities like Berkeley, Georgia Tech, MIT, and a lot more already trust us for their metal cutting needs. Our systems can be found in university makerspaces, high school labs that want to give their students access to high-end manufacturing capabilities. They can be found on production lines for large and small businesses that want to stop outsourcing that work, and in job and machine shops with tight working areas that want high repeatability with a quick return on that investment. And even in R&D and prototyping teams that want faster iteration times and prototype parts that feel like finished goods. So why do they choose us? For one, you get accurate and efficient power. Our systems are configurable for different power levels up to 4,500 watts of pulse power, depending on your needs, and they're accurate up to plus or minus 0.002 of an inch per foot. FabLight systems are also the most affordable on the market. We're able to be so affordable because we're unlike any other fiber laser cutter that you'll find on the market. And that's because this machine has really been designed from the ground up to pack all those features you want in a system that was designed for really efficient manufacturing. In addition, our FabLight systems are running off of just a 110 volt, 20 amp wall outlet and clean, dry air. You can run FabLight on your production line for less than $1 per hour in operating costs. Other fiber laser system suppliers some of them don't even support tube cutting, or they require you to buy a complex attachment for your system, or completely separate systems forcing you to choose between tube and sheet. But not here. FabLight systems can be configured with tube and sheet cutting capabilities that are completely integrated into the system. Our systems are also safety-minded. They come fully enclosed in that Class 1 enclosure with a laser safety window built right into it. There's no need for special safety procedures and safety glasses while the machine is on and running. Everyone in your space is free to walk around with peace of mind. Our systems are also less than half the size of our competitors. Again, because these systems have been completely redesigned from the ground up, it's allowing us to create something really unique for customers that want small form factor with the biggest parts possible. We're able to cut up to 25 inches by 50 inches in round tubes, up to 3 inches in diameter, or up to 2 inches square in rectangular tubes. It really is perfect for businesses and schools that are limited in what new equipment they can add to their small space. Installation is a breeze as well. There are no truckloads of crates with parts that take days to put together or require a team of people to install, nothing like that. There's no cranes, no rigging, no special tools or on-site calibration. What you're seeing on the screen right now, that crate with our FabLight in it, that's what you get. It's packed in a single crate with that built-in ramp. Once you open it up, you can roll it right off on its built-in wheels and into its new home. Lower the feet and you're all set. The 7-inch HMI that I showed you earlier is really intuitive and easy to use too. And hopefully that came through there earlier. There are no clunky menus. You don't need to learn G code or need to interpret anything like that. Our systems can be found in universities across the country with a wide range of students using them in art programs and engineering teams. And most of these campus makerspaces take students from drawing to cut parts for their first time. These students have no experience doing any sort of metalworking or anything like that. They're taking them from drawing to cut parts in less than an hour, no experience whatsoever. It's a really great tool for students who simply want to make the best possible project. And same goes for our, oops, sorry, I'm not forwarding correctly here, but same goes for our FabCreator software and plugins. They do really make it easy for you to turn your parts and drawings into cuttable FabLight files. Again, you saw it, there's no G code to learn or troubleshoot. You're ready to go in minutes. Training can be done quickly, and students, engineers, staff, anyone can be on their way to laser cut parts. So on the right is a list of common materials, precious and exotic, that we've thoroughly tested and cut on our FabLight systems. The main chart in the middle is going to show you some of those more common materials and what thicknesses you can cut up to. The thickness that it can cut is determined by two factors. The power level that you choose, obviously, which our most popular model is that 4,500 watt. All of our customers love that one, or the ones that have it, I should say. And then the customer chooses because it can really cut through thinner materials faster, and it can go up to a 1/4 inch on steel with that high pressure configuration. But just keep in mind that is for prototyping volumes only, not production level volumes. And this leads us to our second factor. So anything an 1/8 inch and above, we really do recommend upgrading to a high pressure system. For your system, if you're thinking about buying one, stick around until the end. We're going to announce that special for you, and I think you'll really like it. So, and I kind of mentioned this already, but a question that we do get often is, can we cut above a 1/4 inch insert material, you know, copper, aluminum, what have you? As you can see, we can cut steel at a 1/4 inch, but that's prototyping volumes only. Anything above a 1/4 inch is really considered plate material, and FabLight systems are built and configured for cutting typical sheet metal thicknesses, which is really 3/16 and below. So here is an overview of some of our pricing and what that looks like for our systems, and this is for our low pressure configuration. If you're ready to move forward, we can help you choose the right systems for your needs. We are booking well into October now, production slots, and we tell customers about this time of the year for us. Some of them heed our warnings, others try to wait it out, but we are already seeing an influx of orders coming in as businesses are looking to spend that last bit of their budget on equipment and trying to take advantage of that 179 deduction. So that does bring up those who qualify for that Section 179 tax deduction. You want to think about your production slot, because in order to qualify, you need to purchase and specifically receive or implement that system into your business by the end of the year. If you haven't heard about it, you need to learn more. We've got a really great article on our website that talks more about how you can take advantage of it. And our sales team can definitely help you out with any questions that you might have in regards to that and whether or not we can fit into that. So now we're going to move into the Q&A. I'm actually going to go back to our machine here, and actually I'm going to switch to our external camera. There we go. I'm going to put some gloves on. We're going to finish out the rest of this workflow. And folks, I know we're at the top of the hour. If you got to go, I really appreciate you sticking around. We're just going to finish up with this part here. So we're going to open our door here. We're going to pull out this easy drawer. Again, really easy to load up material onto this. And we can see our laser cut part here. So we're going to unscrew these tabs. I've got them in tight, apparently. And all we're going to do to get this part, now this part is a little bit complicated. It does have a little more complex geometry, especially because of those slots that we created for this. So this one is a little bit tougher to get out, but still not that bad at the end of the day. And then for the rest of our parts, remember, we didn't want those parts to fall in, kind of kink up like this to get in the way of our cutting head. So that's why we tabbed them. Now, all we do, just pop them out. Got this big handle up here. I'm not going to do these slots because I do know from experience that they do take a little bit of time to get out. But they're not that bad. You can either wiggle them out. I was also taking some of the spare material and just knocking them out really quickly. So that's pretty easy. But there it is. There's our first wall. And then, sorry for that. If there's folks still sticking around, I'm going to show you the assembly of this real quick. So that doesn't roll around on me. Part I actually might have to knock out. There we go. There's our grill wall. Rest of our parts. Excuse me. So sorry about that. Our slots, so that again, the way we designed that slot, that's going to easily fit in there. Got our other one on the other side, just like that. So those two can kind of stand up there. All we do now, take this, slide it right on there. That's one side. That's side number two. We've got our grill top here. Fits right into those notches. And there you have it. There's your grill. Really sturdy, really great stuff. We really appreciate you joining us, folks, today. We enjoyed teaching folks what we can. Again, I don't know if there were any questions. David, if you could check and let me know if there are any questions left from the attendees who have stuck around. We can answer those too.
Looks like all the questions that have been answered, John.
Great. Awesome, folks. Again, thank you for joining us today. We really appreciate it. We are going to send these files out. We're going to send you a ton of information here in the coming days, but thank you for joining us, and have a good one.